All right, so here we are with the elimination method. This is our first example. So take a look at the problem that I've drawn up for us here. We have 5x minus 2y equals 18 and negative 3x plus 2y equals negative 6. And our goal, as usual, is to find the solution, which means if we were to graph these two equations, where would they intersect? And of course, we always know that there are three possibilities. We could have them intersect once, they could intersect 0 times, which would mean there's no solution, or they could intersect infinitely many times. I'll give you a hint. This one is one that intersects once, so we will be finding a coordinate. That means an x value and a y value. So in the last section we talked about the substitution method, which is where we isolated the variable in one of the two equations, and then we substituted it into the other equation. Then we solved. So in this one we notice that neither the first nor the second equation lend itself to easily solving for one of the variables. Now that doesn't mean it'd be impossible. It wouldn't be that tough. We could solve for y maybe in the first equation. We could subtract 5x, divide by negative 2, but it wouldn't turn out as pretty as it did in some of the examples in lesson 1. And that leads us to the question, is there another way to solve this? And the answer is yes, and it's the elimination method. Or as I said in the intro video, some people call this the linear combination method. So the elimination method. I feel like elimination is easier to say and to remember, but linear combination is another title. The elimination method says that every now and then we end up with a pairing of two equations where if we were to add them together, so just like when you were in elementary school and you were adding, you combine columns, right? That, take a look at this column right here, negative 2y and positive 2y. The elimination method points us to situations like this and says it would be very easy to get rid of one of the variables by just combining. So 5x minus 2y equals 18 and adding to it negative 3x plus 2y equals negative 6, so that these two would automatically cancel out. Now if that just seems like, well, why? Why do we care about canceling? Remember that we said in the last lesson that in order to solve for a variable, we need to only have one variable in the equation. We can't solve, let me take this back off again, we can't solve if we have an x and a y. I don't know which one to isolate. Do I isolate x? Do I isolate y? I can't get a solution for that unless I can get rid of one of the variables. So the elimination method says if we just stack the equations on top of each other, now we want to make sure the x's are together and the y's are together, and then we have the equal sign together and the numbers, just the regular constants, together. So everybody's together in their own column. We can just combine the columns so that some of them eliminate. So we're going to get 5x and negative 3x are going to combine to be 2x, right? Because it's 5x minus 3x essentially. We just saw that negative 2y and positive 2y eliminate, they go away. We have the equal sign, and then 18 and negative 6 become 12. And look at that, by combining these two equations, this is where we get the idea of linear combinations. We're taking lines and combining them together. We get 2x equals 12. That's something I can solve. In fact, I know right off the bat that that's x equals 6. And sure enough, that is the answer to part of our solution. We now have the x value. Now, we know that we need to be able to figure out an x and a y value in order to finish this. So let's use a different color and do the same kind of thing we did in the linear combination method, which is once I have a value for x, I could go back to either of my equations. Let's use the second one because it just seems to have smaller numbers. So that's negative 3x plus 2y equals negative 6. Let's find out if x is 6, what is y? So that would be negative 3 times 6 plus 2y equals negative 6. So that's negative 18 plus 2y equals negative 6. Add 18 to both sides. I get 2y equals 12. oh, conveniently, we're actually going to get a same value for y and for x, because in this case y will also equal 6. That's just a coincidence. It's not always the same. But in this case we see that when x is 6, if I plug it into one of the equations, y is also 6. Now let me just show you something kind of interesting. If I were to plug this into the other equation, so it was 5 times 6 minus 2y equals 18, so that's the first equation, and we solved it out, 30 minus 2y equals 18, subtract 30 from both sides, that would give me negative 2y equals negative 12. Look, y equals 6. So I show you that only to say it doesn't matter which equation you decide to plug x into, either way you're going to get the same value of y. And the reason that happens is because that's the solution. The idea is that if I were to graph one of these lines and graph the other one, they'd intersect at one point. Well, in this case, that point is the point 6, 6. X equals 6, y equals 6. That's the point of intersection. Okay, that is the elimination method. Now, I'm going to show you a second example in the Topic 2 video, but take some time to take a look at this, write it in your notes, and then take a look at our second example in Topic 2.